Example 3. Use the intermediate value theorem to confirm that the given polynomial has at least one zero within the given interval. The intermediate value theorem is used to figure out a space where there is possibly an x-intercept. Some of the graphing calculators that you can buy and even Desmos use this idea when trying to find x-intercepts for a function, because if we were to just scan the entire x-axis, it would take a long time to just search for zeros. So if you have a graphing calculator and you want to figure out where there's a particular x-intercept, you actually have to give it bounds. Like you have to say, look somewhere between -3 and +3 to find an x-intercept. The idea being that if at -3 the y value is negative, but at +3 the y value is positive, that means if this function is continuous, somewhere between those two, the graph has to cross through the x-axis. So on a graphing calculator, if you wanted to find an x-intercept and you want the graphing calculator to find it, like something that's a decimal, for example, something that doesn't factor very easily, you have to give it a bound, a lower bound and an upper bound of where to search. The closer you can get to the actual zero, the less time it's going to take for the calculator. So we're just going to verify that this is how this process works. So for this first example A, we're going to take the value -4 and plug it into the function. This will be -4 cubed minus 9 times -4. This is -64 plus 36, which is, hang on, negative, on my calculator, I'm getting -28. And then we'll plug -2 in to the function. So -2 cubed minus 9 times -2. This is -8 plus 18, which is 10. So however this function is working, at -2, the graph is up here, and at -4, the graph is down here. So we know that somewhere between those two values, the graph has to cross through the x-axis, and there's a zero there. Let's look at another example. For example B, we'll plug in -1 first. We'll have -2 times -1 cubed minus a -1. This is -1 cubed is -1, and this will change to a +1. So this looks like 2 plus 1, which is 3. And then let's plug in +1. So this will be -2 times 1 cubed minus 1. This is -2 minus 1. This is -3. So thinking about this graph, at -1, the graph is positive, and at +1, the graph is negative. So somewhere between these, the graph has to cross through the x-axis and give us an x-intercept.